Have you ever imagined a neutron star up close? A world where a spoon outweighs mountains. Tonight, we drift into the densest mysteries known. These objects are born from collapsed stellar cores. Only massive stars leave behind such remnants. Gravity compresses matter beyond atomic structure limits. They are typically only 20 kilometers wide. Yet they hold more mass than our sun. Smallness and heaviness coexist in contradiction. Their density is almost beyond comprehension. A spoonful would outweigh Earth's highest mountains. Matter here crowds closer than nature prefers. Atoms cannot survive in their normal form. Electrons merge with protons under pressure. Matter becomes mostly tightly packed neutrons. Surface gravity is billions times stronger than Earth's. A human could never stand upright there. Weight becomes a cage made from space-time. Escape speed approaches half the speed of light. Light itself bends when leaving the surface. Space curves steeply around their presence. Time runs slower near such extreme gravity. Clocks their fall behind distant observers. Relativity becomes noticeable, not theoretical. Their surfaces are incredibly smooth overall. Mountains there rise only millimeters high. Gravity flattens everything into near perfection. Many spin extremely fast after formation. Some rotate hundreds of times each second. Rotation stores enormous kinetic energy. When magnetic beams sweep past Earth, pulses appear. These rhythmic signals are detected by telescopes. Such objects are known as pulsars. Their timing is unbelievably precise over years. Some rival atomic clocks in stability. Cosmic order emerges from collapsed chaos. Pulses help measure gravitational waves in space. Tiny distortions alter arrival times slightly. They become tools for studying space-time itself. Their magnetic fields can be trillions times stronger. This exceeds anything humans could ever build. Nearby space fills with intense electromagnetic energy. Some extreme ones are called magnetars. Their fields can strip atoms from distances. Magnetism alone can power violent emissions. Magnetars release sudden gamma-ray bursts. These flares can outshine galaxies briefly. Energy escapes from magnetic stress fractures. Their crusts crack under intense internal forces. These events are known as starquakes. Spin rate changes after each quake. A solid crust surrounds their outer layer. It is stronger than any known material. Pressure locks nuclei into rigid structures. Beneath lies a superfluid neutron interior. Friction nearly disappears in this state. Matter flows in quantum mechanical ways. Superfluid motion affects rotation over time. Sudden transfers of momentum cause glitches. Astronomers observe these unexpected spin jumps. Stay with me, deeper revelations are coming. The final truths reshape how reality feels. Some mysteries are closer than they seem. Some of these dense objects exist in pairs. Two remnants orbit each other in tight paths. Gravity binds them in a shrinking dance. As they orbit, energy leaves as gravitational waves. Space-time carries this motion outward invisibly. The orbit slowly tightens over millions of years. Eventually, the pair collides in a merger. The impact releases enormous energy instantly. Space ripples like water struck suddenly. These mergers create many heavy elements. Gold and platinum form in these collisions. Jewelry on Earth began in such events. Some pull gas from nearby companion stars. Stolen matter falls onto their surface rapidly. This process can spin them faster. These are called accreting neutron stars. Infalling gas heats to extreme temperatures. X-rays shine brightly from their surroundings. Matter sometimes explodes in surface bursts. These thermonuclear flashes release sudden energy. Astronomers observe them as X-ray bursts. Such systems help study extreme gravity behavior. Motion near them tests relativity predictions. Physics operates near its known limits. Their interiors may hold exotic matter states. Pressures exceed those inside atomic nuclei. Particles behave in unfamiliar ways there. Some theories suggest quarks move freely inside. Others predict strange new particle combinations. These possibilities are still being investigated. Observations of mass and radius give clues. Different internal models predict different sizes. Astronomers compare theory with measurement carefully. They act as natural laboratories of dense matter. No Earth experiment can match those conditions. Nature provides environments beyond human engineering. They slowly lose rotational energy over time. Radiation and particle winds carry energy away. Spin gradually decreases across millions of years. Some older ones spin very slowly now. Others remain fast due to past accretion. History shapes their present rotation speed. Their magnetic fields also weaken with age. Energy stored in magnetism dissipates gradually. Behavior changes as fields decay. Even in aging, they remain extremely dense. Their structure changes little over time. Gravity continues dominating their existence. Astronomers have discovered thousands so far. Many more likely hide undetected in space. They populate our galaxy in large numbers. Some travel through space at high speeds. Supernova explosions can give them strong kicks. They move alone between the stars. Collisions involving them produce gravitational wave signals. Detectors on Earth have measured such events. These observations confirm merger predictions. Now we approach the deepest connections. The final truths shift perspective gently. Stay as understanding moves closer to you. These objects show matter can exist in extremes. States impossible on Earth appear naturally there. Physics allows more than everyday experience suggests. They prove gravity can overpower atomic structure. Forces inside atoms lose against crushing weight. Nature permits matter beyond normal boundaries. Their study improves models of nuclear forces. Understanding them refines theories of dense matter. They guide physics toward deeper accuracy. They connect quantum mechanics with gravity directly. Two major theories meet inside these remnants. Such overlap is rare in the universe. Heavy elements formed in their mergers spread outward. These materials later build planets and moons. Cosmic recycling follows each violent collision. Gold in electronics traces back to such origins. Platinum used in technology shares this birth. Industry unknowingly uses stellar remnants gifts. Without these events, many elements stay rare. Chemistry of life would look very different. Their existence shapes biological possibility itself. Astrophysics links directly to everyday materials. Distant collisions influence objects in your room. Cosmic history hides in ordinary matter. Their pulses allow precise galactic navigation. Future spacecraft may use them as beacons. Natural signals guide movement across space. Timing variations reveal passing gravitational waves. They act like sensors spread through the galaxy. Space itself becomes measurable through their rhythm. Studying them improves knowledge of stellar death. They mark one pathway massive stars follow. Not all endings lead to black holes. They occupy the boundary between stars and holes. Too dense for normal stars, not collapsed fully. A middle state in cosmic evolution. Their existence confirms supernova theory predictions. Remnants match models of core collapse. Observation supports decades of theoretical work. Temperature on their surface remains extremely high. They glow mainly in X-ray wavelengths. Heat slowly escapes over millions of years. Some possess atmospheres only centimeters thick. Gravity prevents gases from rising freely. Even air behaves differently under such force. Their study requires radio, X-ray, and gamma telescopes. Different signals reveal different physical processes. Multiple wavelengths build a complete picture. Elements forged in their collisions reached Earth. Those atoms became part of oceans and land. Planetary material carries this stellar heritage. Iron in your blood formed in ancient stars. Gold around you traces to violent mergers. Your world contains relics of collapsed suns. These objects are not distant abstractions. Their history flows through matter around you. You live among products of cosmic extremes. So tonight's journey was never truly distant. Understanding them also explains part of you. The universe continues quietly within everything. If this journey quieted your thoughts tonight, gently like the video and return for more. Subscribe and rest as the universe whispers.